All right. Good afternoon, guys. I hope you're having a good conference. My name is Amiram. I'm the founder and CEO of Spotinst, and thank you for joining the session. We're going to talk in this session about how to achieve a serverless experience while running with Kubernetes or Amazon ECS, basically with containers. So let's start. Before we start, let's talk about how it all got started. So the guy you see here with the green shirt, that's me. And my friends here, we were trying to graduate our BSc in computer science. And we had this project called Spot and we basically wanted to find some very clever algorithm to maneuver Spot instances before Amazon interrupt them. So we'll be able to find before that happened and actually locate them in a different Spot instance. And basically, we were able to, it was a big success. It was like the project of the year. And the rest is history. Here we are today. The person to my left is our VP of sales. The person to my right is our head of product. And the person next to him, well, he works for AWS, but it's OK. Let's talk just a little bit about us, who we are. So Spotinst started about 3.5 years ago, 2015. We raised our Series A from Vertex Ventures and Intel Capital. Just recently, we closed our Series B. We're scaling very fast, 120 people in the company, in 4 locations in the world, and expanding. That's Spotinst. Our expertise is basically managing compute workloads on behalf of our customers. We're basically today managing over hundreds of thousands of EC2 instances. What we do is we just provide automation for DevOps that help them to save time and money. By doing that, we're able to save around 60 to 80% by running most of the workloads on Spot instances and growing. What we're going to talk about today is the anatomy of Kubernetes and Amazon ECS. Then we're going to talk about 2 levels of scaling when it comes to scaling containers onto instances. Then we're going to talk about the difference between metric-driven scaling and container-driven scaling. And then we're going to talk how can we achieve a serverless experience scaling. And we'll talk about Spotinst Ocean, which is a product that we actually launched today. So I'd love to give you a brief overview about what it does with Kubernetes. So let's start. So anatomy of Kubernetes or container scheduling in general. So what we see here, we have a master, all right? It can be managed or unmanaged by the cloud provider. For ECS, it's completely managed. With Kubernetes, you probably know EKS, or you can just manage your own, like through kops, or just install plain vanilla Kubernetes. And then we have the nodes. The nodes that you see here, usually called worker nodes, they're running pods or tasks for ECS. And they have something they call kubelet or ECS agent. And this pod is basically responsible to send data and get data from the master to basically schedule containers or drain containers or scale containers on the worker nodes. All of these pods are also connected to something that's called service. Service is a way to bring networking into the containers. So it can be a load balancer, it can be an ingress controller, but basically that's the high-level overview of the anatomy of like a scheduling of containers. It's too far. All right. So let's talk about metric-driven scaling. Metric-driven scaling is something that we basically know very well from autoscaling. Is probably the traditional way of scaling capacity. And what is metric-driven scaling is when a given metric meets its threshold. So what you see here, it's either CPU or memory that we usually have workloads, and we say, if we hit 80%, scale up. If we lower than 70%, scale down. That's a metric-driven scaling. The problem with metric-driven scaling is that when it comes to containers and infrastructure as a service, it causes scaling Tetris issue. And let's talk about what is a Tetris scaling issues. So if you look about this diagram, you would see that we have two levels of scaling. One level is the container level, and the other level is the infrastructure as a service. So basically, if you, as a DevOps, you want to scale a service to 1,000 containers. All right, you can scale to 1,000 containers, but you need to make sure that you will have enough infrastructure underneath to satisfy these 1,000 containers. And then it causes, because containers can be shipped in different sizes, containers can consume 1 gig of RAM or 10 gig of RAM or even 64 gig of RAM. So it causes a Tetris game between the actual infrastructure as a service and the container size. Let's show some examples for that. So in that example, we're going to show how a wrong pod size can cause a Tetris issue. Let's see, we have here a cluster, 3 instances, a large, X large, and a medium. On the large has 2 containers. The X large has 3 containers in different sizes, and the medium has no containers. But if we actually look about how many vacant containers we have in this cluster, we have 1, 2, 3, 4. So that means that allegedly, we have a room to scale additional 4 more containers, right? But what happens if a container in that size of like 3 containers, we would want to schedule that? So with metric-driven scaling, we would think that, hey, we have enough room in the cluster. But in fact, it will not fit. Second example is a wrong instance type. Let's say that we have 2 instances, medium and X large, and that's the current cluster situation. We have 2 vacant containers, and now we want to scale this pod, and we only have 2 vacant containers, so we're missing actually 1 container in order to scale up. So let's bring a new node to the cluster, and for some reason we'll scale up a medium server. It's not going to help us because this guy needs to have a full 3 container size in order to scale up. So we're in a problem here. Another major issue is how do we scale down? If you look at this cluster is 50% utilized, right? The medium server is 50% utilized. The 2 X large server is 50% utilized, and the other medium is 50% utilized. So obviously, we would want to scale down. And if you want to scale down, let's take the most expensive instance, right? Which is the 2XL server. All right, we took it down, but now what? This container cannot be scheduled in the cluster. So because all of that Tetris issues, so there has to be another way of scaling containers, which is not based on metrics, and it should be based on containers. So let's talk about what is containers-driven scaling. With containers-driven scaling, the instance size, type, and lifecycle should be determined based on the actual pod or container requirements. If I have a small pod, I'll get a medium. If I have a large pod, I have a 2XL. If I have 2 small pods, I have a bigger instance. That's the way it should work, right? The infrastructure as a service should be aware of what type and size of containers we want. In addition, when we scale up and scale down, we need to take care of fragmentation because otherwise we'll be in serious troubles. So let's see how scale up should work. If you want to scale up, so we need to introduce a new large server and even replace them with other instances so they will meet the container's requirements. And when we scale down, so from having the X large and the medium, we'll choose very intelligently to remove the medium and migrate the medium container to the X large server because we have enough space. That's a container-based scaling. What about constraints, labels, tolerations? Sometimes when we deploy pods or containers, we put specific labels. This instance should have GPU, right? So we need an instance with a GPU. OK, we'll get you a G2 2XL. Or what if this instance should be, or this container should run an on-demand instance? OK, we'll get you an on-demand instance. This is a container-driven scaling. And what if this server needs to be like low priority? This is not like a real important container, and I would like to schedule it some like, T instances, which is burstable. You can do that as well with container-driven scaling. So basically, when we sum it up, so if the instance size, type, lifecycle labels, taints, tolerations, everything is determined by some magic. So we basically didn't handle infrastructure as we scale up and down. So I call it serverless because we're not dealing with servers anymore. We're actually dealing with containers. And somebody just brings up servers underneath to satisfy our needs. But I don't call it serverless. I call it serverless experience. And let's talk about what is a serverless experience. A serverless experience is first, no management of underlying infrastructure. We don't need SSH to the nodes. We don't need to patch them. Everything should be like with the latest AMI, latest security updates. We don't need to touch them. It all should be managed. Traffic shifting, which you get by the container orchestrations. You can do blue-green deployments. You can route your traffic between service A to service B. You don't need to touch the infrastructure for that. And also, you scale by request. So if your containers need to horizontally scale, that will scale. You'll get more infrastructure. If you need to scale down to 0, you'll also do that. It's utility billing. You'll pay only for what you use. So that's a serverless experience for me. The other thing is fast scaling. When we actually implemented that, what we saw is that what our customers were talking with us is that how do you scale efficiently from 2,000 containers to 16,000 containers? How do you do that? Think about in metric-driven scaling. If you would scale by CPU, it will probably take you a few hours to realize that the cluster is having CPU issues. But if you're scaling based on containers, you're actually realizing, oh, we have additional 14,000 containers to scale, and we'll scale that in one time. And this is where I'm very, very excited to introduce Ocean. Ocean is our newest product that actually does all of what I said just now. It determines the instance type, the instance size, the life cycle, the labels, the tolerations, the taints. It manages the actual traffic shifting. It manages the patch of the underlying instances. It will always bring you the latest AMI. It basically frees you from doing anything that's related to infrastructure management when you scale on Kubernetes or Amazon ECS. We have integration already today for Amazon EKS, so you can basically connect your Amazon EKS. I'll show it how we do it. Just vanilla Kubernetes or KOps, if you guys are using KOPS. And Amazon ECS is coming by the end of the year. How does it work? So what you're seeing here in this diagram is basically Ocean is a layer that works underneath Kubernetes and on top of your infrastructure as a service provider. It identifies which servers it should bring to your cluster based on your actual container sizes. It can scale horizontally or vertically based on your actual pods consumptions. It's a layer that actually, there is a product of AWS that does something like that, which called Fargate. So we'll talk about like this Fargate experience. But basically, as you can see here, it's a layer that abstracts the compute for you and chooses very intelligently which instance type, size, life cycle, and constraints to use for the cluster. Main features is no VM to manage, no need to choose instance types. It's 80% less of infrastructure. Very important to mention that. Everything is running on Spot instances using our prediction algorithm. And also, there is a very robust UI that I'm going to show in a few seconds to manage Kubernetes. We have their world-class auto-scaling, and this is patent pending. It's something that we worked very hard in the past year to release. And you can also achieve horizontal and vertical scaling. Ocean also has on-premise support. Very important to mention. If you have on-premise Kubernetes cluster, you can take Ocean and install it on-prem. What it will do, it will basically discover your cluster on-prem. It will send all of the cluster topology to our SaaS platform. You'll be able to manage your on-prem clusters and AWS clusters from a single pane of glass, which is something that customers asked us a lot. How the architecture of Ocean works. So you have your Kubernetes master. You can choose whatever you want. It can be Amazon EKS, your own master, and so on. And then on your worker nodes, one per cluster, will have to have a controller pod. We call it Spotinst controller. These controllers identify the cluster topology and sends all the information to our SaaS UI. which I'm gonna show in about a minute. And basically, you can discover all the clusters. It will take care of the auto-scaling and all the other things that I've mentioned just by installing this tiny pod. So this is the UI for Ocean. We start with the bottom line. You see how many servers you have, what was the potential on-demand cost of this cluster, and what was the actual cost. So you see, instead of paying about $11,000, you would pay about $3,000. That's about 73% of savings. And you can see once that the cluster is available, you can see in which region you're running it, when you created that, what is the Kubernetes version, what is the CPU and total and memory allocations of the clusters. If we scroll down, so this is a very, very powerful view. What you can see here is we basically wanted to give a visibility of like how much resources my pods are consuming versus how much nodes I'm actually running in the cloud. So here you see nodes versus CPU and memory allocations. And here you can see pods versus CPU and memory allocation. That's very powerful, so you know as you scale up and down, how much instances you actually bought from the cloud, how much it costs you, and it really helps to identify bottlenecks in networking, bottlenecks in performance. Here, on the lower section, you see the distribution, because everything is running on Spot instances. And Spot instances, as you know, they might disappear. AWS might terminate them. So what we do very cautiously, we distribute them across many instance type, sizes, and availability zone. So if we anticipate an interruption in a specific pool, we'll migrate you to another pool. As you can see here, we're declining on this pool and increasing from this pool. And also, you can always monitor your pod status, which is, I think, the most important thing to do in a container scheduling orchestration. You can see how many pods are running, how many pending pods, and how many unscheduled pods you have. Unscheduled pods is basically the situation that you don't want to have in your cluster. And that's what Ocean always does, querying these unscheduled pods and launching the capacity that's needed for the cluster. This is Ocean on-prem. Once you install Ocean on-prem, you can customize the CPU and memory unit cost of your on-premise. And then it will simulate, based on your actual compute in your on-prem, how much it's going to cost you at AWS. So if you're running on-prem clusters and you're thinking about, like, maybe we should shuffle or offload workloads from the cloud to the on-prem or from the on-prem to the cloud, here you can have a very, very powerful view of both on-prem and the cloud. What you can also see here, that's a showback. That's also a very cool feature. If you have multiple deployments, multiple pods running in the cluster, you can break down the cost per deployment, which is very powerful. The last thing is, we always talk about it in the company, if there's no customer traction, it's not cool. So here's like a customer that just tried that with ECS, and he said, just like our auto-scaling realized that it's cheaper or more efficient to run 3 C5s large than 2 C4X large, and we reshuffled the clusters. So not only that it's running on excess compute capacity, but it's also bin packing the application way more intelligently. So you can really get the most out of your dollar investments in the cloud. We're very excited about that, and I think that's kind of like summarizing it. Thank you very much. We'd love to answer any questions. We have a couple of minutes.
And if anyone would like to just raise their hand, I can bring you the microphone. That way everybody else can hear your question.
Thank you very much. Does your infrastructure has an API, correct?
That's correct. We have an API.
Will it work with Jenkins?
We're working with Jenkins. That's correct.
Anybody else? Going once, going twice?
Thank you very much, guys.
Thank you.